So we're going to go over the design steps that we use to come up with our bracket design. We're going to start out with the material. We chose a low carbon steel, and then the thickness is actually going to depend on like your hole size and spacing, and those dimensions weren't given on the spec sheet. But we made one modification to the design, and that was where there were 3 holes right next to each other. We actually moved one of those holes to the other side of the bracket. And then we did our steps for our cold working of the steel. We would first draw out the impressions. You have one channel and one hole that's actually has a little indentation around it. After that, we would bend the edges up to form the corners in the bracket, and then we would cut across the sheet. We're actually going to use a square sheet. Okay, so we're actually going to use a square sheet because that way we can hopefully minimize waste. And then the last step's annealing, and we'll go over all this in a little bit more detail. So you can see our first step, we're going to start out with a square sheet, and hopefully you can see on the second step how it's going to kind of outline. You have 2 sheets there. And so our first step in the actual process, where you have the shaded areas on figure 2, that's actually where you're going to use hydroforming to make those indentions. We chose hydroforming because it's cheap and it's an accurate process. And then our next step would come in figure 3, and that would actually be punching the holes. And one of the big considerations when it comes to punching the holes is that on the corners where you're going to be folding the metal, you want to make sure and use a okay. So on the corners, you have to have a little bit lower clearance because you don't want a lot of burrs, because you're actually going to have to fold parallel to the rolling direction on one of those folds. And so you want to be a little bit more careful with those corners because you don't want burrs that can cause raised stress, localized stresses. Then you go into figure 4. That's where you actually take care of the bending, and you would want to make sure and make little channels along the line where you want to bend the metal, so that way you have less problems with excess metal getting in the way, and you have less stresses in your metal that could cause fractures. Our final step, we would want to anneal this piece because there were the aforementioned stresses from from bending with the rolling direction. And it's kind of outlined in the book that to relieve residual stresses, you would want to heat the metal or the material to about 700 degrees Celsius and just let it cool slowly in still air. Some of the other considerations talked about how you have to fold with parallel to the rolling direction, and while that can cause problems, the low carbon steel will be a fairly ductile material, and that was one of our reasons for selecting it, was that it's easier to work with that when you're making those folds. So thank you for your time, and your feedback will be appreciated.